All right, welcome back to the deep dive. Today we're diving into a topic I think a lot of you will find fascinating: the inner thoughts of role-playing language agents.
Yeah, these are the agents that power things like chatbots or, the NPCs you might encounter in a video game.
Exactly, and as these agents become more and more sophisticated, it's not enough for them to just, spout dialogue.
Right, they need to be able to understand their characters, their motivations, their backstories, all those sorts of things.
To really, inhabit the role.
Yeah.
And to do that, they need some form of internal reasoning, right? Like we as humans, we have this constant stream of consciousness, these inner thoughts that drive our actions and decisions.
And that's what's so intriguing about the paper we're looking at today. Guess what I am thinking? A benchmark for inner thought reasoning of role-playing language agents.
Basically, this paper is trying to figure out how we can actually evaluate and understand the thinking that's going on inside these agents when they're playing a role.
It's about getting under the hood and seeing what makes them tick.
Right. So, we've seen a lot of progress in getting language models, like the ones that power these agents, to be able to reason logically, right? Like step by step, laying out their thought processes. We call that chain of thought reasoning.
Yeah, and that's been really effective for things like problem solving, question answering, that sort of thing.
But when it comes to role-playing agents, we haven't really had a good way to understand or even evaluate that chain of thought. Like we see their actions, we hear their dialogue, but the why behind it all has been kind of a black box.
And that's a big problem if we want these agents to be truly believable, if we want them to genuinely understand the characters they're portraying.
Right. It can't just be surface level. It has to be, deep down.
Yeah.
They need to be able to think like the character would think.
Exactly. And that's where this benchmark RoleThink comes in. It's a way to actually assess how well an agent can generate thoughts that are consistent with a specific character.
And the source material they use is pretty interesting. They've chosen to work with George R.R. Martin's A Song of Ice and Fire, the books that the Game of Thrones series is based on.
Which is brilliant. I mean, think about it. Those books are famous for their complex characters, right? With all their tangled motivations and histories.
Not to mention all the internal monologues.
Exactly. Plus, there's a huge amount of fan analysis and literary criticism available. So you have this incredibly rich data set to work with.
So this RoleThink benchmark is actually divided into two parts: the gold set and the silver set. Can you walk us through what each of those is about?
Sure. So the gold set is all about trying to recover the original thoughts of the characters, the ones that are explicitly stated in the books. They take passages where a character is having an internal monologue, they mask it out, and then they ask the AI to fill in the blanks, essentially.
So it's like, can the AI read the character's mind?
Exactly. And then they compare what the AI generates to the actual text from the book.
I see. So if we think about Ned Stark, struggling with a moral dilemma, the benchmark would be testing if the AI can generate thoughts that are similar to what George R.R. Martin actually wrote about Ned's internal struggle in that moment.
Yeah, and they have some great examples of this in Table 1 of the paper. Like with Ned, the scenario they use involves him facing a really difficult decision, and the benchmark is looking for the AI to capture his thoughts about his family, his sense of duty, all those things that are explicitly mentioned in that scene.
Right. And then what about the silver set? How is that different?
The silver set is more about generating plausible thoughts. It's not about directly matching the text from the books, but about creating thoughts that make sense for the character given what we know about them, even if those exact thoughts aren't stated in the novels.
So it's more like, based on all the information we have about this character, what would they likely be thinking in this particular situation?
Right, and that's where all the fan analysis and expert commentary comes in.
So, for example, they use Tyrion Lannister as an example. And let's say this scenario involves him making a big decision. The reference material would be all the stuff that experts have written about Tyrion's motivations, his past experiences, his personality, drawing from the entire series to create a picture of what's going on in his head.
Yeah, it's like tapping into the collective understanding of the character.
I see. So they've created this pretty extensive benchmark with lots of different characters and scenarios. But how do you actually go about evaluating something as subjective as an inner thought?
Well, they use a combination of methods.
Right.
Start with some standard automatic metrics like BLU and Rouge L, which measure the overlap of words between the generated text and the reference text. But they also acknowledge that these metrics are pretty limited when it comes to capturing the meaning and the character consistency, especially in the gold set where, you could have slightly different phrasing that still conveys the same thought.
So how do they go beyond just looking at word overlap?
They use other language models, like ones trained specifically for tasks like natural language inference.
Ah, so they can check if the generated thought actually logically follows from the scenario.
Exactly. And if it aligns with the character's established traits, they even use GPT-4o, which is a really powerful language model, to evaluate the quality and the relevance of the generated thoughts.
Wow, so it's like AI judging AI.
And crucially, they also include human evaluation.
Of course.
They have literary experts assess the coherence, the emotional depth, and the overall believability of the generated inner thoughts from a character's perspective.
So it's not just about whether it's grammatically correct or logically sound.
Right. It has to actually feel like something that character would think.
Okay, so we've talked about the benchmark itself, how it's constructed, how it's evaluated. But now let's get into how the researchers actually try to tackle the challenge of generating these inner thoughts.
Yeah, so for that, they've developed a method called MIRROR, which stands for memory integration and role reasoning with observation reflection.
Okay, mirror. What's the core idea behind it?
It's a chain of thought approach, which means it breaks down the task of generating these inner thoughts into a series of steps.
I see. So what are the steps involved in mirror?
The first step is memory recall. The agent tries to retrieve relevant memories from the character's past based on the current scenario.
So it's not just like throwing the whole backstory at the model.
No, it's much more targeted than that. It identifies related events from the narrative and retrieves specific memory chunks that are associated with those events.
Ah, so it's like how our own memories work, right? We're reminded of things from the past based on what's happening in the present.
Exactly. And they use some clever techniques to do this. They use embeddings, which are numerical representations of the meaning of text.
Okay.
And they use something called cosine similarity, which basically measures how similar two embeddings are.
So the system is trying to figure out which past events are most semantically similar to the current scenario.
Right. It's looking for the connections in meaning.
I see. And then what's the next step?
The next step is theory of mind thinking.
Theory of mind. What does that mean in this context?
It means that the agent tries to understand the perspectives of other characters, groups, or even elements of the environment. It's about being able to step into someone else's shoes and consider their viewpoint.
So it's not just about the agent's own internal thoughts, but also about their understanding of how others might perceive the situation.
Exactly. They call these other entities objects, and they could be anything that's relevant to the scenario, like other characters, institutions, even physical locations.
Can you give us an example of how this theory of mind thinking works?
Sure. They use the example of Jon Snow, from Game of Thrones, contemplating deserting the Night's Watch. So the relevant objects in that scenario would be, his brother Robb, his commander Lord Mormont, his fellow brothers in the Night's Watch, and even, the harsh environment of the North and the rules of the Night's Watch itself. So the agent would be guided to consider how each of these entities might react to Jon's potential desertion, taking into account their relationships with him, their own motivations, all of that.
So it's like, what would Robb feel? What actions might Lord Mormont take?
Exactly. What are the consequences for Jon within the Night's Watch?
It adds a whole other layer of complexity to the agent's thinking.
It really does.
And then what's the final step?
The final step is reflection and summarization.
Okay.
This is where the agent takes all the information it has gathered, the memories, the theory of mind analysis, and filters out anything that's irrelevant.
So it's like cleaning up the rough draft.
Yeah, exactly. And then it synthesizes the remaining information into a coherent summary of the character's thought process.
So it's not just a random collection of thoughts and memories, but a carefully constructed narrative of what the character is thinking and feeling in that moment. Okay, so they've put all this together, they've created this benchmark, they've developed this method for generating inner thoughts. What did they actually find when they tested it all out?
Well, the first thing they found was that generating these believable inner thoughts is actually pretty hard. It's not as easy as just feeding a language model a bunch of text and hoping for the best.
Right.
And they also found that the gold set, where they're trying to reproduce the exact thoughts from the books, was more challenging than the silver set.
Which makes sense. I mean, even for humans, trying to capture the nuances of someone else's writing is tough.
Yeah.
And how did Mir compare to other approaches?
Well, it consistently outperformed the baselines, which included things like just giving the model a summary of the character or just retrieving memories without the theory of mind and reflection steps.
So those extra steps really made a difference.
Yeah, they did. And they also tested some long context models, which are models that are given a lot of text about the character as input. And those models also performed pretty well, which emphasizes the importance of having that knowledge about the character.
Right. But did they find any limitations with those long context models?
They did mention that sometimes those models can struggle with attention dispersion, meaning they might not always focus on the most relevant information when they have so much input to process.
Right. It's like trying to find a needle in a haystack.
Yeah.
And how did the different base language models perform?
Well, the really powerful models like GPT-4o1 and Claude 3.5 showed strong and balanced performance. Interestingly, the models that are specifically designed for reasoning tasks didn't necessarily do better in this setting.
Which suggests that this is a different kind of challenge, right? It's not just about logical reasoning. It's about character understanding, narrative coherence, all of that.
Yeah, exactly.
And what about the human evaluation? What kind of feedback did the literary experts provide?
So they found that the generated thoughts often had strong logical connections and were relevant to the scenario. But they also noticed that the thoughts sometimes lacked emotional complexity. Like they were better at expressing explicit emotions like anger or sadness, but not as good at capturing more subtle, implicit emotional states.
Right. Those are harder to pin down.
Yeah. On the plus side, the experts were impressed with how well the models maintained the character's voice, using their distinctive vocabulary and style.
So they sounded like the character, even if the emotional depth wasn't always there.
Yeah, and they particularly liked the thoughts generated by Mirror because they showed stronger narrative coherence. Like they effectively integrated past events and motivations.
This wasn't just a bunch of random thoughts. It was a cohesive story.
Right. And overall, the experts were optimistic about the progress being made, but they acknowledged that capturing the full complexity of human thought is still a pretty big challenge.
Of course. So did the generation of these inner thoughts actually lead to better performance on other tasks where the agent is supposed to be role-playing?
Yeah, that was a key finding. When they tested the models on downstream tasks like decision-making, motivation analysis, and just overall role-playing ability, they found that incorporating the character's thought data significantly improved performance.
Interesting. So it's not just about generating these thoughts in isolation. It's about actually using them to make the agent a better role player.
Exactly. And the higher quality thoughts generated by Mirror led to even greater improvements on those downstream tasks.
So the better the thoughts, the better the role playing.
Right. And they also pointed out that having access to these explicit thought processes makes the agent's behavior more interpretable, which is really important for transparency.
Yeah, it's like we can actually see what's going on inside their heads.
Exactly.
And did they look at how the length of the generated thoughts affected performance?
They did. They found that longer thoughts generally led to better performance, but only up to a point. After about 300 tokens, the benefits started to plateau.
So there's a point of diminishing returns.
Yeah. And Mirror was actually able to achieve pretty good performance with relatively shorter thought lengths.
Okay. So it's not just about generating as much text as possible. It's about generating the right text.
Exactly.
And finally, they did an ablation study, right? Where they removed different parts of Mirror to see how each component contributed to the overall performance. What did they find there?
Well, they found that memory retrieval was the most important component.
Okay.
Removing that module led to the biggest drop in performance, both on the benchmark itself and on the downstream tasks. The theory of mind module also had a significant positive impact, and even the reflection and summarization component contributed to better results.
So it really seems like all those steps are working together to create a more effective and believable inner thought process.
Yeah, exactly.
This has been a really fascinating deep dive. So now for the novel notion segment, what are some of the more speculative ideas or future directions that this research sparks for you?
Well, the most obvious application is in games and other interactive experiences. Imagine having characters that can truly understand and respond to the player in a believable way.
Right. Characters that feel like they have their own agency.
Exactly. But we could also think beyond fictional characters.
Okay.
Could we adapt these techniques to understand the reasoning of AI agents in other complex scenarios?
Like what?
Like autonomous vehicles. Could we use a similar framework to analyze how a self-driving car makes decisions in ethically challenging situations?
Instead of just seeing the car's actions, we could actually see a reconstruction of its thought process.
Yeah. Or what about AI assistants that are designed to help people with customer support or technical issues?
Could we model their inner thoughts as they diagnose a problem and formulate a solution?
Exactly. And that would not only make them more effective, but it would also make their reasoning more transparent to us.
Which ties into all the research on explainable AI.
Right. And another really interesting possibility is using this framework to look for inconsistencies between an AI's stated goals and its actual reasoning process.
So, like, if an AI says it's doing something for one reason, but its inner thoughts reveal a different motivation,
Yeah, exactly.
that could be really important for safety and ensuring that these systems are actually aligned with our intentions.
It could.
These are some really thought-provoking possibilities, moving beyond just fictional characters to thinking about how we can understand the decision-making of real-world AI.
Of course, we have to acknowledge that this is all very speculative. Evaluating fictional inner thoughts is already pretty subjective, and extending these approaches to real-world AI agents in complex situations would be even more challenging.
Absolutely. These are just novel notions, ideas to think about and explore further.
Right, and for those of you who want to dive deeper into the details of the paper, we'll include a link in the episode description.
Thanks for joining us for another deep dive. We'll see you next time.